Hello, this session will be on revision on linear relations, but focusing on the following points. And it's the worksheet that was given to you in class. So just make sure you go through these checkpoints to ensure that you can do everything. And we'll be covering all these checkpoints in the following revision sheet. And this will include finding and working with linear equations and graphing linear equations using those three methods that we've covered, analyzing graphs, and we know there are 4 different types with a positive, negative, zero, or undefined gradient. And the last point is comparing and analyzing linear equations. So without drawing them, we are able to identify whether they'll be parallel or perpendicular. So we'll be covering all of these points in the questions that were on this worksheet. So we'll start off with question 1, which asks us to draw 4 different graphs showing a positive, negative, zero, and undefined gradient. Now I've done my best to draw straight graphs or straight lines. It's a bit hard using the writing pad. So we're going to first draw the first type of graph, and that is one with a positive gradient. So first of all, we'll label all our axes. It's very important that we don't forget to do that. I'll do it for all of them now. So please make sure you never forget to label your axes. Alright, so the first type of graph or gradient we can have is a positive gradient. And the way to remember is that a positive gradient, we have to go up the hill. So just draw a straight line going up that hill. So remember, that's up the hill and then that's down the hill. So that means the next type of gradient I can have is a negative gradient going downwards, down the hill. And we can see with the positive gradient, and I'll just write positive here, with the positive gradient, our y values, okay, are actually increasing. As we look at the y-axis and we go across to our line, the values are increasing. Whereas this one here, the values are actually decreasing. Okay, so that's another way to remember if it's positive or if it's negative. All right, the third type of gradient we can have is the zero gradient. And imagine we just have straight ground. Okay, if I just drew a person on the ground, they are neither gaining height or losing height. They're just simply walking along the ground and staying in the same position when it comes to height. And that's why that's called the zero gradient. We can see our y value is not increasing at all. Okay, it just at that point was 2. Y can only be 2 at that point. And the fourth type of gradient we can have is undefined, and that's instead of a horizontal line, a vertical line. And this is where x can only be 1 point. Just say it was a positive 3 there. Well, I would say x is only positive 3. And that will be my equation for that straight line. Whereas this one, I would have y can only be positive 2. So these 2 equations are special. Whenever you see in the equation only a y, it should ring a bell that you're either going to have you will have a horizontal line. And if you only see an x, it's going to be a vertical line, which is undefined. We'll just label that. And I sort of say to remember it's undefined because we can't both be going up and down the hill. It doesn't really make sense. And of course, if you were to calculate the gradient, because there is no run, so just say from this point to that point, which is just say y was 2. Okay, so for this point, we've got 0. And to get from that point to that point, we have to rise 2, and there is no run. And we know gradient is rise over run. So if my rise was 2 units, and my run was 0, because I haven't moved either side, you put that into your calculator, anything divided by 0 is an error. Okay, that's why we say it's undefined. Using the gradient to calculate the gradient, we can't actually calculate it because there is no run. So remember, to calculate the gradient, you have to go between 2 points. So if these are my 2 points, I have a rise of 2 units, no run. That's why I've got 0 down here. And Whereas this one, if I go from this point, just say where y is 2 and this point here, okay, and say x is 2, do I have a rise to get from this point to that point? No, there is no rise. So I would have m equals, well, 0 divided by, because I have no rise to get from that point to that point. I'm just walking across, and then I walk across 2 units, which is my run. And 0 divided by 2, it's not undefined, it's simply 0. Okay, that's why we get a gradient of 0. So just keep in mind that when you divide something, so if we have 0 divided by a number, in this case 0 divided by 2, it's 0. Whereas 2 divided by 0, we can't say it's 0, and we can see that they're two different calculations. And this isn't undefined. It doesn't make sense to divide something by 0. Now, our next question, question 2, it asks us to complete the tabular values for the following rule or equation, and then also plot the linear graph. So the first thing we have to do is find some, finish our table and get some points, and simply plot those points on our graph, and we're done. All right, so we know that to plot points with this table, with the table of values, we put in some x values. In this question, the x values have been given to us, and usually it's a good idea to have 0, to include some negative x values and some positive, just so your line can cover more than one quadrant. Now, to do this, we have to simply sub in or substitute the x values into our equation to find the corresponding y values. And we'll do one at a time. And because this table of values, it's going in a pattern, we've got -1, 0, 1, 2, 3, 4, so going by ones, then there should be a pattern in our y values. So we can really only have to calculate the first 2 or 3 values of y by substituting them into the equation, and then we can just figure out the pattern. If you can't figure out the pattern, then keep substituting until you've filled out the whole table. So we'll just write the equation down. We've got y equals 5x plus 7. And I'll just draw the table of values. And I'm sorry for a crooked table of values, but it's a bit hard doing it on the writing pad, but I'll get better as I go. All right, so now to do this, we'll show some clear working out. So starting off with when x is -1, so when x is equal to -1, we're going to find out what our y value is. So with our equation, instead of x, I'll be putting -1. So we've got y equals, and I know that in between my 5 and x, I've got 5 times x. Now you can write 5 times x, but we should really substitute with brackets to get into the habit of doing that, plus 7. And if I have brackets and a number outside the brackets, there is an invisible times there. If you want to write times, you can, but you don't have to, because you know that that's sort of invisible. And now 5 times -1 is -5 plus 7, and y will equal +2. Just be careful with your negative numbers, and you can just enter that into the calculator. And now we'll have a 2. I'll change my color. I'm going to put numbers in for y, and that's it. So this is telling me a point. So when the point is when x is -1, y is y is +2. And that's the point I have found. Now I've got to find the next one when x is 0. Now we know that we can see this equation is in the form of y equals mx plus c, and because of that, I can see what my y-intercept is. So a shortcut is when x is 0, okay, imagine x is 0, I'll have 5 times 0, which is 0, plus 7. And therefore the y-intercept, or when x is 0, is simply 7. And that's something you need to remember, that when x is 0, we find our y-intercept. And then when y is 0, we find our x-intercept. So that was a shortcut for me. And you can actually see if we had 5 times 0, we'd be left with 7. And now I've got 2 and 7, and I can see what the pattern is, but I'll just do one more number just to make sure I'm on the right track. So next number is when x is equal to 1, +1, I will have y equals 5 times 1, just put it in brackets, plus 7 5 times 1 is 5. 7 plus 5 is 12. And I'll put 12 in my table of values. And now I can see what the pattern is, and that, oh no, yep, and that I'm going by fives. So 12 plus 5 is then 17. 17 plus 5, 22. Sorry, it's a bit squishy. And plus 5 is 27. And plus another 5, I have my 32. Sorry that it's squishy. And just double check that I'm doing the right thing. If I sub in 5 into my equation, I will have 5 times 5, which is 25, and 25 plus 7 is 32. So I've done the right thing. And that's it. So I've done my first step, which is to fill in a table of values. And just remember, these are all points. So for example, this one here, this is when x is 1, y is 12. And now all you have to do is plot these points on a graph, and you're done. Now I've just tried my best to draw a straight graph. I've put the table of values just down here so we can see our points. Now I'll just rub this off and label my axes properly. So my next step is, of course, label our y-axis and our x-axis, and also write the equation that you're drawing just above the graph on near the line, just so we can see what the equation is for each straight line. Okay, now when, or really before you draw your graph, you should just have a look and see what values you'll be plotting on. And I can see that my x values go from -1 to +5, and that's not much at all. This 5's a small number, and it's not going to take up too much space. If I look at my y values, I start from 2 and go all the way to 32. Now, if I wanted to, I could go from 1 to 32, go 1, 2, 3, 4, 5, 6. But you don't actually have to do that. Maybe we can go by 2s or by 4s. And just keep in mind, and also I sort of left a lot of space up here because all these y values are positive, and I don't really need too many negative y values. I've drawn all 4 quadrants because my line will be going across sort of all 4 quadrants, and they're important. But just keep in mind that, well, I don't have any negative y values that I'll be plotting on, so it's important to have enough room for my positive y values. So I'll start with my x-axis. Now with my x-axis, I'm just going to skip every second line, just so it's not so squishy. You could do every line if you wanted to, because like I said, I don't have too many values. So that can be 1, 2, 3, 4, and +5. And I'll have -1, -2. I'll just go to 5 just to keep it even, I guess. So that's +1 to +5. You can write them all in. I'm not doing it just because it's a bit hard on the writing pad, and to -5. So imagine I've just numbered them all. Now with my y-axis, the scale for your x-axis, so here I'm going by, I'll just fill them in now, by 1s. Your y-axis doesn't have to go by 1s. It can go by 2s or by 4s. As long as you've ruled up your axes accurately and each interval for the x-axis is even, and the same for the y-axis, that's fine. But you don't have to have the same values. So for example, for my y values, I'm not going to go by 1s. I'll go by 4s. So this is going to be 4, and then 8, and then 12, and then 16, 20, 24, 28, 32. And I can pretty much stop there, but I'll just go one more ahead and write 36. And you can see that my scales for my y-axis is different to the scale of my x-axis, and that's fine. And like I said, for my y-axis, I chose to go by 4s, simply because my y value reaches 32, and it's going to look, I guess, untidy and too squishy when I have 32 lines that I'm drawing. And imagine when we have values like 100 or 500 or 1,000. That's where it's going to be quite tedious drawing 1,000 lines. So just keep that in mind. And now all we have to do is plot these points. I'll change my color just for the fun of it, I guess, and keep that blue. Okay, so when x is -1, my first point, y is 2. X is -1, y is 2. Now, because I'm going by 4s, 2 would be halfway, so just there. Okay, and with some points, it may not be exactly halfway, but as long as you estimate the correct position, that's fine. All right, x is 0, y is 7. Like I said, I don't have 7. So 7 would be halfway just here. Whoop. Oh, for some reason, it's being silly. Okay. My next point, when x is 1, y is 12. So x is 1, y is 12. That's easy, just there. When x is 2, y is 17. So x is 2 and y is 17. So I've got 16, 18 will be in the middle. So 7, oh, sorry, yeah, so 17 will just be there. And x is 2. Put it there. X is 3 and y is 22. X is 3. 22 will be halfway between 20 and 24. So right in that line. Sorry, I don't know why it keeps doing this. All right. Let's see. X is 4. Y is 27. So we've got 28. That will be 26. So 27 will be just halfway. And last point. X is 5 and y is 32. So x is 5. Y is 32, just on that line. And it's going to be much easier for you to do it when you're doing it on paper, not on a writing pad. And now all we have to do is join these lines up. Now imagine I'm using a ruler. It's a bit hard to use this ruler that I have, so I'll just do my best doing it freehand. But imagine I was using a ruler and I didn't do a good job, sorry. But imagine all those points were nice and were all on the straight line, and I've done my question. Okay, like I said, I didn't use a ruler on this last bit because it's a bit hard to use a ruler on the writing pad. And that's all you have to do. So just remember, label your axes. Before you draw your scale, think about, are you going to go by 1s, 2s, 4s, depending on how large your x values are or how large your y values are. And it's you're allowed to have 2 different scales. My y-axis went by 4s, my x-axis went by 1s, and that is fine. But as long as each gap for the x and y-axis are even. Okay, now our next question asks us to state the equation for each of the following lines by finding the gradient and y-intercept. Now we know that the equation of a straight line can always be put into the form of y equals mx plus, oops, it's just frozen, 1 second. Sorry about that. Y equals mx plus c. Okay, now you should know what m is and what c is, but just in case you've forgotten, m is the gradient and c is our y-intercept. And with the gradient, m is rise over run, and the rise we look at our y values, and the run we look at our x values. And we know that to find the gradient, we need to have 2 points, and it's the distance, it's the, you can say, journey traveled between these 2 points. Depending on what you're looking at, it could be with time or just height and distance on the ground. Depends on what the rise and run relates to. And if you remember in our first example in class, we had Bill, I think it was, climbing up a hill. Okay, and if he started from this point and got to that point, okay, we can see it's one straight line, so it's one gradient. The gradient never changes on a straight line; it's always the same, and which is like this hill will never get steeper or easier for Bill. It'll just be the same steepness all the way through. And to calculate the gradient, we have to start from this point and that point. And when Bill gets from that point to this point, 2 things are changing. One, the height is changing, and also the distance on the ground is changing. So by him walking from that point to that point, two things have changed at a constant rate. And that is what the gradient relates to. All right, so I'll put this back here. Now with these, so I'll just zoom in a little bit too much. All right, so we'll focus on A. Now with A, all you got to do is pick 2 points that you want to focus on. Now I can't write on this paper, so I'm just going to show you without writing. So just have to listen carefully. Now to find the gradient, you need to pick 2 points. It can be any 2 points you want. Just make sure the points are clear to you. Try not to get anything that's 0.4 or 0.5, unless, for example, here we can see if they're showing us it's 0.5, then that's accurate. Otherwise, pick points that are accurate and clear to you. So I might just pick this point here and that point there. So the next step is to check your y-axis and its scale. I can see it's going by ones. Every unit is 1, 1, 1. And the same with my x-axis. And just keep that in mind, because if you look at some of the other graphs, we can see here our y-axis, it's not every one, it's every second one that is 1 unit. Just keep that in mind. So from this point to that point, I am rising, so rise over run. Before we actually do that, just check your gradient. Are we going up the hill or down the hill? I can see I am going up the hill, not down the hill. Therefore, this gradient is positive. That's our first step. And now we do our rise and run. So I have a positive gradient, and our rise is from this point to that point. I have to rise up 1, 2, and imagine we're going up an elevator, okay? You can't just walk across straight up the hill. You now have to, or we just say we're in a hotel room, we're on the ground floor, we get in our elevator, go up 2 floors, 1, 2, then walk across to our room 1. And that 1 unit is our run. So if I just move this to the side, sorry about that. So back to what we were doing, our rise is 2, our run is 1, and we have a positive gradient. So we can say m is equal to 2 over 1 is positive. 2 divided by 1 is simply 2. And I have found the first part of my equation, which is m. And just remember, I forgot to mention, to find the equation of a straight line, all we need is m and c. Y and x are just stay y and x, representing our y-axis and x-axis and the relationship between them. So we've got m and c that is what we have to find. Okay, so we found our gradient, which is 2, x stays there. And now what is c? Now c is easy to find when looking at a graph. C is simply the y-intercept, and I can see the y-intercept is -2. So I will write -2. And that is my equation for that straight line. I'll just bring it back onto the page. Okay, so every straight line has its own equation, and we can find it by finding m, which is rise over run, our gradient, and by finding c. And the first step to find the gradient is to check whether your line is positive or negative. Just remember, up the hill or down the hill. Next one that we'll do will be this one here. And I can see that I am going down the hill instead of up the hill. So the first step is my gradient. I'll just clear the page. My gradient is going to be negative no matter what happens. And now, because I've taken care of that, I don't have to worry about negative values or positive values. I know my gradient is negative, and that's it. So now all I've got to do is pick 2 points that are clear to me. Now all of these 3 points are clear because they've put in brackets x is -0.5 at this point. So they're making it clear for us. And we can use 0.5. But if you don't like decimals, then you can avoid that and simply have the rise and run from this point down here to this point up there. And I might just do that. So I've established my gradient is negative. And now let's see what my rise and what my run is. So from this point to that point, so once again, we're going up the elevator. How many steps am I taking? How many floors am I going up? Now be very careful, check your y-axis. If you go 1, 2, 3, 4, you're making a mistake. 1 unit is, we skip 1. So you ready? 1, 2, 3, 4, 5, 6. So my rise was 6 units to get from one point to the other. And now for me to walk to my room, so back, just do it again. 1, 2, 3, 4, 5, 6. There I am. For me to get to across to that point, be very careful again. Don't go 1, 2. Check your x-axis and its scale. 1 unit is all the way across, and we skip 1. So 1. Okay, and I can see x is 1 there. Like I said, do not write -1 down here because we've taken care of our gradient. We know our gradient is positive, and all we're going to do is now count how many units from that point to that point. So don't even bother writing down negative or positive. Just count how many steps are you taking, and that's it. And now 6 divided by 1 is simply 6, or sorry, -6. And that's m. So for my equation, I have found y equals -6x, but I still have to find c. And that's quite easy. Look at my graph. C is our y-intercept where the line crosses over the y-axis, and there is c. My y-intercept is, and it's actually showing me the point, when x is 0, y is -3. So the y-intercept is -3. So therefore my equation is y equals -6x minus 3. And that's the equation for this straight line here. If I just move it, okay? And that's all there is to it. So for the other ones, because we're running out of time, I'll just write the answers for you. Just remember, rise and run between 2 points. D has a negative gradient, so you should have had a negative gradient. And C is a positive gradient up the hill. And I'll just write the equations for you. So here are the equations for C and D. That's what you should have had. And just quickly looking at D, the reason why there is no y value for the y-intercept, it's because it's simply 0. You can see a line cuts through the origin, and whenever it cuts through the origin, we can see y is 0, and of course x is 0 at that point as well, which is why there is nothing there. Technically you can write +0, but we know that 0 is nothing, so which is why we had y equals -4x. And yeah, that's it. Now we're on to question 4. And question 4 asks us to, we're given the equation, and even though it's got brackets and it looks way different from y equals mx plus c, it is still a linear equation. And we know that a linear equation is a linear equation when the powers of y and x are always +1. So we can rearrange it into this form. So 4a is asking us to rearrange it into y equals mx plus c. To rearrange this into the form of y equals mx plus c, we can see y has to be the subject, which means y has to be on its own and equal to everything else. And when it's in this form, we can see the gradient and we can see our y-intercept, which is why it's important. So to turn this equation into this form, the first thing we do is whenever you have an equation and you have to solve it, your first step is to remove the brackets by expanding. And we'll do the same thing here. So we have 5 times y and 5 times -1. So if you've forgotten expanding, there's invisible times there. So we start off by expanding our brackets. So 5 times y is 5y minus 5 equals 3x. And 3 times a +3 is +9. That's our first step done. Now your next step is to, the y is going to be staying on this side. I've got to get rid of this -5 here and also that 5 there. And the first 5 we get rid of is this one here, the one that's sort of alone and away from the y. Okay, we'll leave this 5 to last because it's next to the y, so we leave it till last. If you did want to get rid of this 5 first, you can, but just remember, well, opposite of 5 times y is to divide by 5. But just remember, you have to divide this by 5, this by 5, this by 5, and the 9 by 5. They all have to get a turn because they are all separated by a negative or a positive. So just keep that in mind. So opposite of -5 is to +5, and I'll +5. So that's now 0. So I'm left with 5y equals 3x. 9 plus 5 is 14. Okay, and I'm almost there. Just one more step. Get rid of this 5. And I have 5 times y here. and the opposite of times is to divide by 5. And when doing this, please be very careful. These two terms are separated by a plus, so they have to get a turn each. So we must divide the 3x by 5, and we must divide the 14 by 5. It's very, very important. And do it separately instead of all over 5, so you can see it more clearly. Now, 14 divided by 5 will give us 2.8, so we can't turn it into a whole number. Now just leave it as an improper fraction, but keep in mind that it is 2.8. So if you were asked to draw it, you'd obviously put it in your calculator and locate 2.8 on your axes. And the same with 3 and 5. We can't simplify 3 and 5 anymore, so therefore I'm done. So the equation in the form of y equals mx plus c is, now see how the x is sitting on the top with the 3x? You can leave it like that, but I guess the proper way, or the clearer way of writing it, is having 3 over 5 and then having x just sitting in the middle. Okay, that x is still sitting on top, but it's sitting in the middle on this one, so we can clearly see the rise and the run. But both are correct, and here we've got plus 14 over 5. Okay, so I can see my gradient and I can see the y-intercept. So if we have a look at questions B and C, it asks us to state the gradient and then to state the y-intercept. And I can do that. So for C and D, for B and C, so I'll just change the color. So for B, state the gradient. Well, the gradient is 3 over 5. And for C, state the y-intercept. Well, the y-intercept is simply 14 over 5. Okay, you can leave it in fraction form. And if you wanted to, you can just write 2.8. Okay, but you don't have to do that. But like I said, 2.8 is important when plotting it onto a graph. Now for D asks us to then find the x-intercept. Now we know that we can't actually see the x-intercept when we have an equation in this form. We can only see the gradient, we can only see the y-intercept. So we have to do some working out to find the x-intercept. And if you remember, to find the x-intercept, we have to make y equal 0. To find the x-intercept, I'll be using the equation that was given to me in the question, which was this one here. You can use the one that you have rearranged into the form of y equals mx plus c. They're both the same equation, just one's been rearranged and looks a bit different. But the reason why I'm using this one is just in case I made a mistake on the test, to avoid me also getting the x-intercept wrong. I'm just going to do the safe thing and use the original equation that was given to me, just in case I have made a mistake by rearranging. So to find the x-intercept, we have to say, well, when y equals 0, okay, and we know that when y equals 0, if I quickly drew a graph, okay, y and x, at the x-intercept, the line crosses the x-axis, which is that point, sorry, just there. Okay, y has to be 0. Okay, that's why we, and the same for if we had to find the y-intercept, just say it was here, x has to be 0. So just keep that in mind in case you've forgotten. So when y equals 0, here's my y. I'm going to make that y equal 0. So I'm going to have 5 bracket, just write it as it is. Instead of y, we write 0, take away 1 equals, and we've got 3. I'm going to expand this side just to save me a step. So 3 times x is 3x, and 3 times 3 is positive 9. And on this side now, I've got 0 take away 1, because instead of y, I've substituted 0. And so 0 take away 1 is simply negative 1. Equals 3x plus 9. And remember, in between the bracket and a number, there is times, and 5 times negative 1 is just negative 5. So negative 5 equals 3x plus 9. Now I have my x that I have to solve for. So the next step is, well, I'll bring the 9 to this side to make x on its own. So opposite of positive 9 is to take away 9 on both sides. And negative 5 take away 9, I have negative 14. Negative 14 equals 3x. Now, you can switch this around if you don't like having x on this side. That's no problem. But I'll just leave it as it is. And my final step is to then I've got 3 times x, so opposite of times is to divide by 3. And I'm going to bring the x to this side, so my final answer, I will have x first. So x equals, and 14 divided by 3 I can't do, so x is equal to negative 14 over 3. And that's your answer. To write it as a decimal, you would have 4, and because 6, it's 4.6666, so, and 6 it continues on, so you just have 4.6 and that dot on top. But like I said, just leave it in negative, leave it in fraction form, and that's it. So we have found, with this question, we found the gradient and y-intercept by rearranging our equation into this form, and then to find the x-intercept, we had to make y equals 0, and we use the original equation just in case we made a mistake with our one that we rearranged. Now, next question, question 5. It asks us to sketch the graphs of these two. And if you remember the first question, whenever you only see one variable, in this case I only see a y, not an x, it should give you a hint. We're either going to have a horizontal line or a vertical line. Now, sketch means to just quickly draw an axis. You still have to use a ruler, but we don't really have to do a scale, and I'll show you what I mean by that. So, so question 5a. And we've got y equals 4, or sorry, negative 4, and for b we have x equals positive 3. So imagine I'm using a ruler. It just takes me a long time to do it on the writing pad. So I've used a straight line. Oh, sorry, I made a straight line with a ruler. So y, x, label your axes, and the same for this one here. Y, x. And I'll just change the color for my line. So with this, it's saying y is negative 4, or y can only be negative 4. So imagine negative 4 was just down here. Doesn't really matter where it is, as long as you label that one important point, which is negative 4. Okay, since y can only be negative 4, my line will be horizontal, or a 0 gradient, and I'm done. And for this one here, x is positive 3. Well, positive 3, just say it's over here. Write down that 3, and then draw your vertical line, your undefined line, because x can only be positive 3. Y can be anything else. X can only be 3. Here, x can be anything. X can be 1, 2, 3, and so on, but y can only be negative 4, nothing else. And that's it. Now, question 6 and 7, they're asking us to use 2 more methods on how to draw a straight line. Our first method we used on the revision sheet was a table of values. This one here, question 6, asks us to sketch the following using the x and y intercept method. Okay, and if I have a look at this equation, it is not in the form of y equals mx plus c. And B asks us, does this method require the linear equation to be in this form? And the answer is no, because using the x and y intercept method, all I have to do is make x equals 0 to find the y-intercept, and make y equals 0 to find the x-intercept. And I can do that without it being in this form. If it was in this form, I could locate and see my y-intercept straight away. If x was 0, I could see it straight away. But here, I'll just have to have some more working out. So I'll just write the question up. So to find the x-intercept, so I'll just write, I'm finding my x-intercept. Okay. To do this one, I have to make sure I say when y, I should have put when, sorry, but when y equals 0. So when y equals 0, I'll sub it into my equation. I'll have 2x take away, obviously negative 5 times 0 is going to be 0. Okay, equals negative 10. So I'm left with 2x equals, that's 0, so equals negative 10, divided by 2, and x equals negative 10 divided by 2, that's negative 5. And I have found my x-intercept. So I'll write this point to finish off this part of my working out. So remember, when y is 0, x is negative 5. So x comes first, so we have negative 5, and y is equal to 0. So we'll put 0. And that is one point that I'll be using to draw my straight line. And the second point is when I find my y-intercept. And to find the y-intercept, well, in this case, it's when x has to equal 0. I'll just draw a line to separate them. So when x equals 0, now in this case, I'm going to make my x 0, which is over here. So I'm going to have 2 times 0, take away 5y, sorry, just froze, is equal to negative 10. Now 2 times 0 is simply 0, so I'm left with negative 5y equal to negative 10. I know my next step, well, I've got negative 5 times y. I've got to divide by negative 5, which is the opposite of times. Divide by negative 5. Now here is where you have to be careful. We can see we are dividing two negatives, so two negatives make a positive, and 10 divided by 5 is 2. And write it as a point. So when x is 0, so x comes first, y is positive 2. And now all we have to do is plot these 2 points on a graph, and we're done. So now to draw these 2 points for the following equation, so write the equation next to the line you'll be drawing. It's important that we do that. Equals negative 10. So the line for this equation, and it does tell us to sketch, so we don't have to do a scale in this case. All we got to do is sketch those 2 points, and I found those 2 points when x was 0 and when y was 0. So when y was 0, x was negative 5, and when x was 0, y was positive 2. So they're the 2 points we had before. So now, doing my first point, x is negative 5, y is 0. There it is. Okay, and it's a good idea. You actually have to show these 2 points on your graph. You can just show negative 5, I guess, but you can also write the point, which is a bit better. And then here, x is 0 and y is positive 2. X is 0 and y is positive 2. And my line will be passing those 2 points. And if you get your ruler, I'll just change my color. Oh, actually, I won't use a ruler. It's a bit too hard. I'll do my best to pass these 2 points. Well, so imagine that was a really straight line passing these 2 points. And we're done. Sorry, I can't use a ruler because it doesn't really work. All right, and it did say sketch, so we didn't actually have to do the scale. But even so, even if it didn't do a scale, it is still accurate enough. Just make sure I did count 1, 2, 3, 4, 5 units and 2 units above. So question 7 asks us to sketch the following linear equation, but using a different method, using the gradient and intercept method. It's sometimes called the gradient and y-intercept method. So the intercept is referring to the y-intercept. So if you don't see y-intercept sometimes, just intercept, you know it's the y-intercept. Now for B, it asks us, does this method require the linear equation to be in the form of y equals mx plus c? The answer is yes. We can't use this method unless our equation is in this form, because that means if it's not in this form, we can't see our gradient and we can't see our starting point, which is the y-intercept. Now, for question 7, if you go to your checkpoints, okay, if you've forgotten how to use this method, we're going to be going through these important points. So just have a read if you have forgotten. It is on your paper. So we'll just go back down to question 7. Now, I'll just write my equation. So my first step is to ensure that it is in the form of y equals mx plus c. So I'll just write it up here just in case I've forgotten what that looks like. Y has to be the subject and has to equal everything. So here is my y. It's already on this side, which is, I guess, a starting point. And there are 2 steps involved. One, moving the x to this side, and my second step is then moving the 3. So, like I said, if you choose to remove the 3 first, you can. Just remember, if you divide everything by divide the y by 3 to cancel it, you must divide the x by 3 and the 6 by 3. So my advice is the first step is to remove the number or variable in this case that is furthest away from the y, and that is the x. So I will be left with, that's a positive x, so I have to subtract x from this side and take away x from there. So I will have 3y equals 6 take away x. And my final step is to get rid of my 3. because I've got 3 times y, I just have to divide by 3. Cancels, and remember everything on the other side that's separated by addition or subtraction gets a turn. So 6 divided by 3, and of course x divided by 3. It's very important. So I'll be left with my equation, y equals, I know that 6 divided by 3 will leave me with a positive 2. I've got a negative, no negative down here that I'm dividing by, so it will stay negative. And it's just x over 3. Now, it is in the form of y equals mx plus c, but I can see my x is on the end instead of being first. So I'm going to rewrite this by putting the x over 3 first. Just when doing this, make sure you check to the left whether it's positive or negative. That's a negative x over 3, so I write negative x over 3. That's a positive 2, so don't just write 2 like that. The invisible positive, we now make it a plus. So we can see the positive sign, which is plus 2. Now with this, we've got our equation, and you might be thinking, well, what is my rise and run for my gradient? Where's m? X is sitting on top. Just remember, there is an invisible 1 next to the x, so I really have a third or negative third. So we can actually write our final equation by showing that 1/3, which is important so we can see our gradient. And remember, just like before, our x can sit in the middle. When it sits in the middle, it's actually on top, but it's sitting in the middle so we can see our third clearly, so my rise and run. And of course, we've got plus 2. So finally, I've rearranged it into this form, and now that was my first step. I can now continue with the gradient and y-intercept method to draw my graph. Now, for question 7, I've just drawn the graph. I've done the best job I could. And now we'll be using the gradient and y-intercept method to draw the line. So with this, our starting point now is positive 2, and I've just shown that point here. It would be good if you could label your scale. I'm not going to do it now because it look really messy, but it's easier on paper. But I've shown when y is positive 2, here I am, and that is my first point. So I can use green. I'm going to circle that point or emphasize on it. That is our starting point, and we actually plot that point on. That is a point where our line will be cutting through. Now, what we should have done first was to see if our gradient was negative or positive. And I can see I've got a negative gradient, so I'll be going downhill, okay, or down the hill. So going down that way, which means yes, you can still have a rise and a run, but instead of a rise, we are really going down. So keep that in mind. So just if I take this out, so I know it's negative going down the hill, then I have 1 over 3. Okay, so that's my rise or my y-axis, and that's my run. Okay, so the rise, we either go up or down when starting, depending on whether it's a positive or negative gradient. And negative means we start going down first. Now with the run is always to the right. So I'm just going to write that word here, right side and our left side. Okay, so whenever we do the run, even if the gradient was a negative or a positive, it doesn't matter, we always move to the right when starting off. So keep that important tip in mind. We always go to the right for the run. The rise, when starting off, it might be up or it might be down, just depending on whether our gradient is negative or positive. So first point for this equation, starting point is 2, the y-intercept, and now I am going downhill, and my rise is 1. So down 1 unit. Now don't plot the point. That's not where our point is. We haven't finished our journey. So down 1, and now our run is 3, and we move to the right. So down 1, and then 1, 2, 3, and that's where my point is, right there. Okay, and then keep going. Do the same thing. So down 1, and then across 1, 2, 3. So we're on the x-axis, and x is 1, 2, 3, 4, 5, 6 here. So I can see my x-intercept. And keep going down 1, and the run is 3. 1, 2, 3. So down 1, 1, 2, 3. Down 1, 1, 2, 3. I don't know why it keeps doing that when I try and plot a point. All right, and I can see my points are lining up to form a straight line, so I haven't made a mistake. If you had a point that was just say out here, then obviously you've made a mistake. Just go back and check. Now, we have enough points here that we can join up, but I want some points on this side. So to start plotting points on this side here, we just do the opposite of what we did to begin with. So instead of going down one and moving to the right, for the opposite now, we'll go up one and now move to the left for our run. So whenever we move to the left for our run, we're actually doing the opposite. So now we're going to go up one and move to the left 3 units. 1, 2, 3, and that's 1 point. And again, move up one, 1, 2, 3. Move up one, 1, 2, 3. And I can stop there. And now all we have to do is join up our points. Now I will try and use a ruler, but it's too hard to use a ruler. So imagine I'm using a ruler and joining that didn't work, sorry, joining my points. So imagine I actually that's not working, did join my points. I would have a line going like that. And make sure you cover those points. I haven't done a good job of it, but imagine it was like that. Okay, I am sorry, but there should be one line on that passing through those points that we plotted. Okay, so looking back at the question, it is very important that you understand the steps involved. And the first step we did, which answers question B, is we have to put it in this form, y equals mx plus c, otherwise we can't see our gradient and we can't see our y-intercept, which is our starting point. Now we are on our last page, and these questions do not require us to draw a graph, which is really good, so save me some time. Now, question 8 asks us to determine the equation of a linear function with a gradient of -2 and an x-intercept of 3. And if we look at 9, it's asking us to do the same thing to find an equation of a graph which passes through now these 2 points. And question 10 has information as well. It says it has a gradient of 3 and passes through this point. So these 3 questions, we are doing the same thing, finding the linear equation, but we have different information given to us. Now, the hardest one out of all of these would be question 9, simply because it has more working out, or the most working out compared to these 2. So you just have to read what the question is asking you and figure out what is given to you already and what do you have to find. And with question 9, unfortunately, nothing is actually given to us. And we can see, so with question 8, it tells us with gradient -2. And that saved us a lot of working out, because when we get to question 9, you'll see what will happen. All right, so we'll start question 8. So we've got, it tells us a gradient of -2 is equal to -2. Oh, this is question 8. And the x-intercepts of +3. That was given to us. And now all we have to do is figure out, okay, what do we have so far? To find a linear equation, or to determine it, we know we have to have this, y equals mx plus c. All I have to do is find m, find c, and I'm done. And guess what? Question 8 actually tells us what the gradient is. M is equal to -2, because we know m is the gradient. So far I have y equals -2x plus c. All I have to do now is find my c. And now the other bit of information is this. It tells us the x-intercept equals 3. Now to do this, we know that we have to be given a point to sub in the x and y value and then solve for c. But there is no point given to us that's quite visible. If I compare this to question 10, I can see they actually give me a point which I can use. So what's happening here? You have to just keep in mind the x-intercept is actually a point. And it's an important point because the x-intercept, which is 3, that means y has to be 0. So that's the point that's given to us. When x is 3, y is 0. And we knew that because we know the x-intercept, y has to be 0. And that's the point given to us. And now that's my x value, that's my y value. Sub in the value for x and the value for y, solve for c, and we're done. So you ready? If y is, so we can write some working out. So we're going to sub in this point here, when x is 3, y is 0, into our equation, and let's go. So y is 0, 0 equals negative 2 times x. X is 3, so times 3. We should always substitute with brackets to get into the habit of it, and plus c. Now I've got negative 2 times 3 is negative 6, so I'm going to have 0 equals negative 6 plus c. Okay, I've got to get c on its own, so the opposite of my negative 6 is to add 6. That will give me 0, but of course I have to now add 6 on this side. So c equals positive 6. And I'm done. I have found c, which is my part here in my equation, and which is my y-intercept. So now our final step is to write the equation. So the equation is for, and we found it from the information given to us, the equation is, I'll do it on the bottom, y equals, so m was, what was it? M was negative 2, we've got x, and it's plus 6, because 6 is positive, and we're done. So we found that equation from the given information. Now our next question, question 9, asks us to determine the equation of a linear graph which passes through these 2 points. So this one will involve the most working out of those 3 questions. So we'll just write, we've got question 9, and we're given these 2 points, and we have to find our linear equation. And we know that the linear equation, we have to find m, we have to find c, and we're done. Now, we in this case, we have to start off by finding m, our gradient, and we know that the gradient is the difference between 2 points. So we have these 2 points that belong to a straight line. We can't see, we don't have a graph, so I can't just go rise over line and count my points, so I have to use another method. And that is simply, because it's a difference, we can use this formula just to help us to remember, or you can just do it mentally. We've got y2 minus y1 over x2 minus, x2 minus x1. And we know that subtraction means finding the difference between these 2 points. And that's all we're doing. And it's a good idea to just label so you don't make a mistake. This is our first point. So x is 1 and y is 1 here. Either one can be your first point. And x is 2 for our second point and y is 2 for our second point. And now sub these in. Now when substituting these in, just make sure you're careful with your negatives. So we've got y. Now a way that I do this to never forget the negatives, we've got a takeaway here and a takeaway there. Put them in now so you won't forget it. Now y2 is negative 1, so we've got negative 1, y1 is 2, and then x2 is 3, and x1 is negative 3. And we can see that 2 negatives here will make a positive. So now we have m equals, well, minus 1 minus 2 I know is negative 3, over 3 plus 3 is 6. Simplify this. I know 3 is a factor of 3 and 6. I can see I have one negative, so my gradient will be negative. So I can now place this negative and let it sit in the middle and divide them both by 3, and I can see I have a half. And I have found m. So far I have y equals negative half x plus c. So now all I have to do is find my c value, and to do this you can pick either point you want. You can pick the first point or the second point, sub in the x and y value to find c. So I'll start a new page. Okay, so this is what I have now. I found my gradient, negative half x. Now I'm going to pick one of these points and sub it in. Doesn't matter which one you pick, you'll get the same answer if you do it correctly. And don't be scared of fractions. So I might just, let's see, pick this point here because I've got a 1 and I guess it seems easier. So I'm going to sub in. So sub in this point here. So you must make sure your working out is nice and clear and write every step that you do. And remember, 3 is my x value and negative 1 is my y value. So now instead of y and x, I'm going to put 3 for x and negative 1 for my y. Okay. I can keep the same color. So we've got, instead of y now, negative 1 equals, now negative half. In between the half and the x there is multiplication times, and x is 3. So we should really substitute with brackets. You can see you don't have to for this one, but I like that, sticking to that habit. Okay, and now that 3 is really over a 1. You can ignore the brackets if it's confusing you. I can't simplify my 2 and 3, so if I multiply these together, I will have -1 equals negative times a positive will be a -3/2. 1 times 3 is 3, 2 times 1 is 1, plus c. Now I can see that you can use a calculator, but 3/2 I know is 1.5. But remember, this is just a number. If it helps and you want to write 1.5 for now, you can and bring it to that side. But that's just a number in fraction form. So to bring it to this side, I have to, instead of, if it's negative, I have to add 1.5 or 3/2, which is 1.5, and add 1.5 to this side. That is now 0. Now I'm going to have c equals, now I'll put my c on this side. Now -1 plus 3/2. Now you can use your fraction skills and you'd have -2/2 plus 3/2. Or you can just use your calculator. So actually, if I write it out, so I've got -1 plus 3/2. You can do it mentally because you know 3/2 is 0.5. But to use your fraction skills, I know my 1 is over 1. So times them both by 2 to get the same denominator. So I've got -2/2 plus 3/2. Now -2 plus 3 will leave me with +1. And I keep the same denominator, which is 2. So that's it. C is equal to 1/2. I'll just put it here because I can't fit it on the bottom. And I have found my y-intercept. Now, please don't let your fraction skills hold you back. Just remember, you've got a calculator to help you. And with fractions, we still have to bring it to the other side. And you can just put it in your calculator, but leave your answer in fraction form. Don't write decimals. You can write decimals if it's helping you with your working out, but your final answer should be in fraction form. So the final thing we have to do is now write our equation for the information given to us. So imagine I had room on the bottom. I would have y equals, I had -1/2 for my gradient, x, and now c is a +1/2, so I write +1/2. And we're done. So I guess it was a coincidence having 1/2 and 1/2 for the gradient and the y-intercept. But you should have had that for your answer. So question 10 asks us to find the equation of a line which has a gradient of 3 and passes through this point. So you can see how with this question we have now skipped a whole bit of working out, which was to find the gradient. They're actually telling us the gradient. And here's a point we can sub in the values for x and y and we're done. So for question 10, we have m gradient is equal to 3. So far I have y equals 3x. I haven't found my y-intercept, so I've got plus c. And they've given me this point when x is 1, y is -2. So sub in the x and y values for this point. So we'll have -2 equals 3. X is 1, so just times 1 plus c. 3 times 1, we do times first, of course, is just 3. So -2 equals 3 plus c. To bring the 3 to this side, we have to then take away 3 because it's positive, take away 3. So c will equal, now be careful, we have -2 minus 3, so c is -5. I found my y-intercept, so therefore the equation is y equals 3x minus 5, and we're done. And just remember, the 3 came from the question. They actually gave us the gradient. We had to find the y-intercept by subbing in the x and y value and solving for c. So our final question is question 11, and the question, we are now analysing linear equations and coming to conclusions. So it asks us to compare the pairs of linear equations and state whether the graph of each pair will be parallel or parallel, perpendicular, or neither. Okay, they can't be both parallel and perpendicular. They can be either this one or that or nothing at all. So these two keywords, you have to remember what they mean. So we'll start with parallel. Okay, so parallel lines are lines where they go in the same direction, have the same gradient, okay, so the same slope, and they never meet. They're parallel lines. And just the way to remember is in the word parallel, we have two L's which look like two parallel lines. Well, that's the way I used to remember. So basically, for question 11a, they've given us these two equations, y equals negative 2x plus 4 and y equals negative 2x plus 12. So to see, when analysing graphs to see whether they're parallel or perpendicular, you have to make sure they're rearranged into the form of y equals mx plus c. The reason for that is we are going to be comparing the gradients of these two equations. So with question 11, A and B, they're done for us. They're all in the form of y equals mx plus c. So keep in mind, if you are asked to do this, you may have to rearrange it into that form. Now, so parallel means they have the same gradient, and I know that the gradient here is negative 2, the gradient here is negative 2, because we know that's m and m, which is the gradient. That means if they have the same gradient, the same slope, that means that they'll be parallel without even having to draw them. So 11a, you can say these two, imagine I wrote two equations are parallel, and just state your reason why. You can't do any working out, but just state it. Because they are the same or they are equal. That's fine. So that's showing me, or your teacher, that you haven't taken it like a yes and said yes or no, they're parallel. You've actually explained that you understand. All right, so the next one now is the harder one, which is perpendicular. Okay, so just quickly, in case you've forgotten what perpendicular means, two lines will be perpendicular when they cross at 90 degrees. So imagine I drew a proper plus or like a cross, okay? They cross at 90 degrees, which means every angle on this cross, it's 90, 90, 90, 90, which we know a full revolution gives us 360 degrees. So perpendicular lines cross at 90 degrees. If I drew these two lines, you can see they are not perpendicular because there is no right angle. And we know that symbol here means a right angle. So they cross at 90 degrees or at right angles. And really, if you're given a question to ask whether they're perpendicular or not, you should see this symbol here. Now, with perpendicular lines, we have to analyze their gradients, okay? But we have to think of we have to remember the keyword reciprocal. So I'll just rub this page off. So before we look at that word reciprocal, two lines or two equations when drawn will be perpendicular if the gradients equal -1 when multiplied together. Okay, so a formula we can use is simply saying gradient 1 times gradient 2. So we're multiplying two gradients, will have to equal -1 if they will be perpendicular. So you can just write this formula down to state that you understand what you're doing, and this sums up this sentence here. So we're going to get our two equations. So if I use 11a, now I know these two were parallel, but to test and to see if they're perpendicular, all I have to do is get the two gradients, so -2 and -2, multiply them together, and if I get a -1, they will be perpendicular, and that's it. Now I know that with these two equations, if I got -2 times -2, it won't give me -1. I'll get a +4, and therefore they can't be perpendicular. If I go to B, so my two equations for B, I've got 3/5 and then a -5/3. Now, my first clue is, well, one's a positive and one's a negative, which means if I multiply these two gradients together, I'll get a negative gradient. So far I'm on the right track. So you can see the question, I've got 3/5 for one gradient and -5/3 for the other. So what I'm going to do, so for B, I'm going to get their gradients, gradient 1, which is 3/5, times gradient 2, which is -5/3, and let's see what it gives me. Well, you can multiply it out, or you can simplify before you multiply. Cancel my 3, cancel my 3, cancel my 5, cancel my 5. They're all 1. And please do not forget that negative. So my answer, would be negative 1 over 1. Sorry, it came out a bit big. Okay, and of course 1 divided by 1 is simply equal to 1, but I have a negative 1. Don't forget that negative was there. And because I got a negative 1, I will say, therefore, these two equations are perpendicular. Please make sure you summarize your findings by writing a short statement at the end. And that's all you have to do. To test and see whether they're perpendicular, you multiply them together, and if it equals negative 1, that's it. They'll be perpendicular. And you don't even have to draw it. It saves us from having to draw it to prove it. So just make sure when working it out, you just write this formula saying gradient 1 times gradient 2 has to equal negative 1. Do the test. If you get negative 1, yep, these two equations are perpendicular. If you don't get negative 1, well, you just say these two equations are not perpendicular. And a trick is you'll know if they're perpendicular or not if these two numbers are being multiplied with its reciprocal. So that's the key word I was mentioning before. And the reciprocal, I'll just write it up here. Reciprocal. Okay, so for example, if I had, well, I'll stick with 3 over 5. The reciprocal of 3 over 5 is a number multiplied with 3 over 5 to give us a 1. Okay, that's what we mean by the reciprocal of a number. And 3 over 5 multiplied by another number to give me 1. The trick is just flip 3 over 5, so I have 5 over 3, and they will all cancel out to give me a positive 1. So the reciprocal of, try another example, 2 is simply to equal a 1, all I got to do is flip the 2. I know the 2 is really sitting on a 1, so if I flip that, I will have a half, and 2 times a half will give me a 1. So the reciprocal of 2 is a half, or the reciprocal of a half is 2. All right, if I have, we'll do one more example. If I have 3 over 11, the reciprocal of 3 over 11 is 11 over 3 because it equals a 1. Okay, now when it came to linear equations, we had to have the negative reciprocal. Remember that? We had to have m1 times m2. Yes, it had to equal the reciprocal, but the negative reciprocal. So in your textbooks, you'll see that keyword, reciprocal, and with these types of problems or questions, we need the negative reciprocal. These examples here, both of my numbers were positive, and I was getting their reciprocal because I was getting 1 as my answer. But with perpendicular lines and equations, we have to get a negative 1. Okay, so hopefully that has helped, and yeah, just keep practicing and let me know if you have any more problems. Thank you.